Okay, our quick look at the calendar shows us that test number 2 is coming up very soon. Today is our last day of new material, although in reality there isn't anything new today. We're just going to take a look at some complicated derivatives. No new rules, just putting together the old rules maybe in new ways. So that's the plan for today. On Friday, our next class for Halloween, we'll review for test number 2, which is coming up Monday. Also, steel drum was due last class. Several people turned it in, but several people didn't. So hopefully you got steel drum done. You put it in the green folders right now. And then officially pipeline is due right now. So put those in the green folders as well. Any questions on the calendar? Okay, so then again on page 46 in the packet, up here at the top, it just says today is all about practicing with our new derivative formulas to find derivatives of complex functions. So there's a strategy guide that we are going to look at very quickly, but it's a nice reference for you to have when you're working on these hard derivative problems in the activity and also in the homework. But first, pop quiz that doesn't count for anything and isn't collected. I've got a bunch of blank derivative spaces here, so can you guys write in as many as you remember? This is one of the few non-group work things, so just on your own, see how many of these derivative rules you remember. It's okay if you don't know them all. It's probably problematic if you don't know any of them, but fill in as many as you can. Okay, so I said we would very quickly look at this strategy guide, so I'm just going to jump to this third thing here, the product rule. So for example, it says what the product rule is. The derivative of f times g is that stuff symbolically. And then it tells you what to look for. Does the function that you're trying to take a derivative of consist of two functions which are multiplied together? If so, you are in product rule. And what to do, you use the rule to find the derivative of the product. And then there are a few cautions here. The derivative of f times g is not maybe the intuitive answer, f prime times g prime. We have to do the full-fledged product rule. Another caution, an expression like cosine of 3x is not a product, right? Cosine of 3x, that's cosine of stuff. It's not cosine times 3x. Don't do a product rule there. And then one more caution, if there's a product inside part of the function, then you're going to be using a different rule before getting to the product rule. For example, if I had x times e to the x, the whole thing to the 5th power, there's definitely going to be a product rule happening, but it is not the first thing that happens, right? The first thing we see is stuff to a power. So we do our power rule first, bring the 5 down, copy the stuff, raise it to the 4th, and then finally we get to look at the details of what's inside and we say, oh, it's a product rule when we do the derivative of this stuff inside, okay? So you got to know when to use the product rule. So, so you can look over that sheet in more detail later. And then on the next page, there's a big old chart, which gives you a bunch of examples. And so for example, this x to the 5th sine of x, I think it's the third one in the chart. What kind of a function is that? Like what rule are we going to use there? That's our product rule, right? Because it's x to the 5th times sine of x. So we notice it's a product, we use the product rule, and there's the answer. So you can look at these guys later on too, just to kind of give you some specific calculations that you can double check. And they do get more involved as we get down towards the bottom. And all we have on our agenda before the group activity is these two problems, these two complicated derivative rules. So let's start with part A. So we're trying to find the derivative of this thing. So first, let's use good notation. If this is g of x, what's good notation for the derivative? It's g prime of x. Okay, so we have to decide what the fundamental rule is, what the first rule is here. Is this stuff to a power? It's to an x. When we do our power rule, it's got to be some x's raised to a number, just like the example I made up there in black. That's a power rule because it's some x's raised to a number. But if there's an x up there where the number is, it is not the power rule. Which one of which one of these things in this table looks like a number raised to the x? Is the a to the x. So that is our fundamental rule here. A to the x. It's a number raised to the x. So that's what we're going to use. So according to our fundamental rule, a to the x, I'm just going to copy this so we have it in front of us. It's a to the x times ln of a. That's our rule for just a straight number to the x. So in our case, we have a to some stuff. So we follow our basic rule. It should be a to the x, but now it's a to the stuff. So it's just copying that whole thing. Oops, copying that whole thing exactly as it is. Root 2 to the x ln of x. So that is this part. And then the next thing I see is times ln of a. So I'm going to put that next. So times ln of what? Root 2. That's the a value, is the guy sitting down below. So this thing right here is this guy. But then we've got more to do. It's times the derivative of the stuff, because we applied a rule that was a number to x, just simply x. And if it's anything more complicated than x, then it's the chain rule coming in. So that power, the x ln of x, is the stuff that we're about to take the derivative of. So let's find that. So we need the derivative of this guy, and we're going to put it here. And so when I see x ln of x, I have to think it's just a brand new derivative problem. It's how would we find the derivative of x ln of x? That is a product, right? It's x times ln of x. So product rule goes in here. So product rule says first times derivative of the second. So x times, what's the derivative of ln x? 1 over x. And again, if you've got that memorized, then we can kind of churn right through this. But if you have to look up every single basic derivative rule, and I'm not saying basic to like demean you for not knowing all of them. I'm just saying like there are fundamental rules, and I'm calling them the most basic kind. And if we don't know those, then I'd expect we're going to get lost in all the shuffling back and forth between the middle of this product rule where we are and using some of the basic or fundamental derivative rules like 1 over x. Continuing the product rule, plus second times derivative of the first, ln of x times 1. So this is almost perfect. It's almost done. What did I forget to include? Parentheses, because that product rule is the derivative of the stuff. That whole thing is the derivative of the stuff. And so that whole thing needs to get multiplied by all the previous work. So that's it. If you felt like simplifying because you wanted to check an answer against an answer key, the only thing that I see is this x times 1 over x becomes 1. That's just about all we can do. Okay, let's look at part B. I equals e to the cosine of ln of x squared plus 1. So fundamentally, what is this first and foremost? It's definitely a bunch of chain rules. What's the first? This is e to some stuff. Right? That is what it is first and foremost. So I'll put up here my derivative of e to the stuff rule. So what's the derivative of e to the stuff? E to the stuff times derivative of the stuff. Okay, so let's start writing our answer down here. So good notation. What's good notation for the derivative of y? So y prime is fine. The other option is dy dx. Either way is okay. Okay, so as we saw, it's e to the stuff times derivative of the stuff. So I copy the whole thing as is. And then I have to multiply by the derivative of the stuff. I'm going to highlight in yellow the stuff. So I need the derivative of that whole power cosine of ln of x squared plus 1. Yeah, and so we see cosine of some stuff, and lo and behold, it's yet another chain rule. So what's the derivative of cosine of stuff? It's negative sine of the stuff. Negative sine of the stuff. And then we're supposed to multiply by the derivative of the stuff. And so I'm going to highlight now the new stuff, because this was now cosine of stuff. So the stuff is now just the ln x squared plus 1. By the way, this is one of my favorite things about the smartboard is that I highlighted yellow and blue on top of each other, and what happened? Green. Awesome. Okay, so now we're looking at the highlighted blue/green stuff. So I need the derivative of ln of x squared plus 1. That's ln of stuff. What's the derivative of ln of stuff? It's 1 over the stuff times the derivative of the stuff. So 1 over the stuff, x squared plus 1, times the derivative of the stuff, and now I'm going to run out of highlighters, so I'm going to just circle the new stuff, the final stuff, is x squared plus 1. What's the derivative of x squared plus 1? 2x. That is the answer. So you got to keep very careful track of what the stuff is, because oftentimes it changes. And we might have to apply the chain rule like 3 or 4 times like we did right there. Okay, so here's some good news. On the next page, it says your group activity is actually your homework. So you're going to be spending the next almost hour just doing your homework. It's 1 to 73 odd on page 180 to 181. Now here's the deal. I recognize that 1 to 73 odd is something like, what, 34 problems? Am I doing that right? No, 37 problems. And normally I do not assign 37 problems. So here's what I'll say. If you don't have time to do all of them, I recognize that this is a 37 is much longer than a normal homework assignment. So if you can't do all of them, at least make sure you do some from a variety of these problems. Don't just do like the first 10, because those might be the easiest 10. Just kind of skip around. In order to get credit for this homework, I don't need you to do all 37. If you do at least 20, you'll get full credit for this homework. I'd like you to do all of them, but I recognize that you have other responsibilities, all right? So at least 20, and if you're not doing all of them, make sure you jump around. Don't just do the first 20, okay? All right, so you're just going to get started. Raise the flag if I can help. The answers are in the back of the book, but I went ahead and kind of screenshotted them. So I'll project this up here, and you can check your answers just by looking up here, so you don't have to keep flipping around in the book.